In the last video, we were given the equation of a line or an equation of a linear function, and we were asked to graph that relationship. So the relationship between x and y was given in algebra form, and we were asked to graph that relationship, as in express that relationship in picture form or diagrammatical form. This time we're going to go backwards. So let's say you were given a line and you were asked to find the equation of that line. Okay, let's start. There's four examples, or four fairly simple examples that we're going to go through just to demonstrate the idea. Okay, a few things to note. First of all of these, well, actually all the examples we're going to look at have a distinct or an obvious y-intercept. Okay, so a obviously visible y-intercept. Okay, and that can be read off directly from the graph. You don't even need to do a table of values or anything for that matter. Secondly, we can work out the gradient quite easily by, if you want to visualize your right angle triangle, you can just pick a convenient point, go across, go down until you form your right angle triangle, and then work out your rise and run, and you do the m equals rise over run, and you've got your m and your c, and then you've got basically you can use those as part of the equation y equals mx plus c, okay, to sort of fill in those missing values. The other way, which I actually think is probably a bit more tedious, but I guess if you're asked to do this way, then you should know how as well, is to fill out a table of values. Okay, the table of values may be useful if you're asked to use the 2-point gradient formula. You can use 2 points from the table as well. Okay, I guess with enough practice, just reading it off the graph is in fact quite easy and very simple to do. So I'm going to do things both ways here so you can see how it works. All right, let's have a look at the first one. Okay, the first one, okay, you can see here that the y-intercept's obvious and it can be read off the graph. So the y-intercept here is 1 or positive 1. So I'm going to put +1 here. Okay. The next thing we need to read need to work out is the gradient. Okay, and we can do this by using a right angle triangle. Okay. So if you want, you can, I'm just going to draw a triangle there, and just to make it fairly obvious. You can also use the 2-point formula as well. Okay. So there's our right angle triangle. Now, always from left to right. Okay, when we're determining gradient, we sweep from left to right. What is happening? Okay, it's actually going downhill. It's going to be negative. So this rise is in fact a fall. So it's falling, it's going to be negative. Okay, the run is 2. Okay, we've got 2 squares across. The fall is negative 4. Okay, so m is equal to rise over run, which equals negative 4 over 2, which equals negative 2. We now have enough information to write the equation of the line. Okay, and the equation of the line is y is equal to, okay, I might just write the general formula first. Okay, mx plus c, we have the m, we have the c. So y is equal to negative 2x plus 1. Let's just fill in the table of values while we're at it. You notice that the x values have not been filled in. Okay, remember we did talk about this idea of independent and dependent variables. X is the independent variable, and it's usually on the horizontal axis. That's by convention. The y value or the y variable is the dependent variable. Okay, that means that we can actually really come up with any x values that we want, and that's by convention. I guess a habit of mine is negative 1, 0, 1, and 2. Well, we don't have to do it that way. We can go negative 2, negative 1, 0, and 1. It actually doesn't matter, just as long as the points are convenient. The y values we have to work out by using the x values. So when x is negative 2, okay, the y value is 5. So x is negative 2, y is 5. When x is negative 1, we read the y value here of 3. when x is 0. Now you know what happens when x is 0. That gives us the y-intercept, 1. And when x is 1, y is -1. Okay. So you can see here that as x goes up by 1, the y value goes down by 2. So -2. And that's where this -2 comes from here. Okay. And we have the y-intercept here of 1 when x is 0. So we can use the table of values as well to work this out. Let's have a look at the next example. Okay. Let's first notice that the gradient's an uphill. So going from left to right, the gradient, okay, is rising. Okay, so it's going to be a positive m. Okay. Now the other thing as well that's worth noting is that the y-intercepts may be difficult to work out. It's not exactly 1.5. It seems to be maybe 1 2/3 or 1 3/4, in fact, or 1.75. So rather than reading it off the graph, we're going to have to use maybe something slightly different here, or a different method to help us work out maybe precisely what the y-intercept's going to be. Okay, if it's a whole number and it's an obvious whole number, then it's easy to read, but this one's not so obvious. So let's work out the gradient first. Okay. In fact, we could use this value here, okay, as one part of the triangle, and just pick another convenient point. So maybe this point here. Okay. So maybe what I might do is I'll just draw a dotted line so I can see that. Okay, that's a rise of 2. What's the run? Okay, 1, 2, 3, 4, 5, 6. Okay, so m. Okay, we know the formula, rise over run. So the rise is 2. Okay, over the run of 6, and we can simplify this fraction. The rise over run is 1 on 3 as a simplified fraction. Okay, so m is actually, it's equal to 1/3, it's a fraction. Okay, I think what we might do now is we might fill in the table of values. Okay, but notice that I'm not going to use 0 because it's difficult to read, that one there. Okay, the y-intercept. So let's come up with some useful, maybe some whole numbers. Okay, that might be of some value. Okay, -2. We got 1 and maybe 4. Okay, so -5, y is 0. Okay, -2, y is 1. When x is 1, when x is 1, y is 2. And when x is 4, y is 3. Notice this table of values. As the x values go up by 3, the y values go up by 1. So the run, you have to sort of move along horizontally quite a bit for just a small rise. Moving along quite a bit for just another small rise. Okay, so that's where the fractional gradient comes from. So from that, could we perhaps work out the y-intercept? Okay. We could estimate it here to be about 1 2/3. Let's use some algebra. Okay, we know that the formula is going to be in the form y equals mx plus c. We know the m already. Okay, 1/3 x plus c. Let's pick a point from the table. Any convenient point will do, because if we can substitute in a y value and an x value from any of the columns of this table, we can work out the value of c. All right. So I think a nice one to use would probably be, actually no, let's use one with positive numbers, because positive numbers are always easier to work with. So x equals 1. When x equals 1, y equals 2. Okay. So 2 is equal to 1/3 times 1 plus c. Okay, 1/3 times 1 is just 1/3. Okay, so 2 minus 1/3 is equal to c. Okay, therefore c is equal to 1 2/3. Okay, which is 5/3. So what would the equation be? Okay, we now have our value of c. Okay. Y is equal to 1/3 x. Okay. So 1 2/3. I think our initial estimate was correct. I think I did say either 1 2/3 or 1 3/4. So that's 1 2/3 here. Okay, plus, but I'm going to express it as a improper fraction. Plus 5/3. So that's the equation of that line. Okay. Let's have a look at two more examples. Okay. This one, okay. Negative gradient, it's going downhill. Okay, so we expect a negative m. We could read the y-intercept directly and go off the graph. Okay, so c is equal to -3. Okay, if you can do this and it passes through a whole number, this is, I guess, sort of an obvious step. And it's worth something because this is going to form part of the formula or part of the equation of the line. So do that first. Can we work out the gradient? Okay. In fact, you can read it off the graph as x goes across by 1, okay, goes up by 1, y goes down by 1. Cross 1, down 1, cross 1, down 1, cross 1, down 1, so on and so on. Rise over run, well, it's falling, -1, when we're moving across +1. Okay. Let's work out the table of values first. So if you're struggling to understand that, let's maybe work out, let's use the table of values, and if you know how to use the 2-point formula, we can use the 2-point formula for gradient. So let's do that. All right. So x, I might just use the values that I've used in the past. The -1, 0, 1, and 2. I've used that quite often. Okay. You don't have to, but it's convenient. Okay. -1, y is -2. When x is 0, y is -3. When x is 1, y is -4. X is 2, y is -5. Okay, so I think we can see that y values are dropping by 1 as the x values go up by 1. Okay, so let's see if we can work out what's work out the gradient. Okay, now from the table of values we can see also that this is the y-intercept. Okay, when x is 0, the value of y is in fact identical to the y-intercept, or in fact it is the y-intercept. Alright, let's use the 2-point formula now. So m is equal to y2 minus y1 over x2 minus x1. Now 2-point formula means we need to pick 2 points. So why don't we pick this point here? I'm just going to star them, and maybe this point here. Okay. There's negative numbers everywhere, so I'm not going to escape those. So this is going to be our x2, y2. So I might just label these x2, y2, and this one will be our x1, y1. All right. So y2 minus y1, so -5 minus y1, which is okay. So that's our y2 minus y1 over x2 minus x1. 2 minus -1. So -5 plus 2 minus plus 2. Okay, that's going to be -3 over 2 minus 1. That's going to give us +3, and that gives us a gradient of -1. Okay, so we have our gradient. Okay, we have our y-intercept. Okay, which we can read off the table or from the graph. So what's the equation going to be? Okay, y is equal to -x, because that means -1x, okay, plus c, well, plus minus, so it's going to be just -3. And that's the equation of that line. Okay. Last one. You've seen this one before, horizontal line. What's the gradient of a horizontal line? Okay, if I think about that. There's no rise or fall. The rise is 0. 0 over any run is going to be 0. That's a nice one there. So it really doesn't matter what the x values are, does it? When x is -1, y is -2. When x is 0, y is -2. When x is 1, y is -2. And so on. When x is 2, y is -2. the y values are all the same. In fact, the y values have nothing to do with the x values in this sense that x could be whatever you like. This line just keeps going on and on and on. Doesn't really matter. So given that it's obvious here that the value of x does not affect the value of y, okay, the gradient is 0. This one's very obvious. Y is equal to -2 because the x, well, there's no gradient, 0x plus c. Well, the x is effectively taken out of the equation. Okay, and that's one way that we can use to find equation of lines. Okay, there are other methods, I'm sure, but I've tried to do something here that's fairly straightforward for you to understand, using triangles, using the 2-point formula, reading it directly off the graph. If there's a grid, you can just sort of read it off just by counting squares. So there's different ways of looking at it, but the end result should be the same.